1 year of ChatGPT, therefore 1 year of serious conversation popularly around generative AI.
So people who previously, weren't software engineers, weren't developers, are starting to think about how AI applies to them and their businesses. The broader set of possibilities has much more visibility because GPT and some of the image technologies such as Midjourney have just made it accessible to so many more people. There are other applications where we've sort of realized that it's something that needs further development. And I think, there's more sort of realism now versus a year ago about what GPT's good at and what it's not so good at.
All right, Dr. Philip Cowans, serial AI entrepreneur, CTO, Cambridge academic or ex, and of course, tech and AI venture partner at Pi Labs since 2019. Few individuals better equipped than you to commemorate the first birthday of ChatGPT, which is what we're doing today. Jam-packed schedule for us to cover, right? We want to do it succinctly enough, obviously, for it to appeal to our busy audience, while also being able to tap into as much of the intellectual capital sitting across from me on the table. The first thing I want to talk about is what we've learned from the past 12 months, right? So 1 year of ChatGPT, therefore 1 year of serious conversation popularly around generative AI. Yeah. Benefits and downsides, perhaps, a lot of discussion around hype, what has been positive, what has been negative.
Yep. Yes, and that's a really interesting topic. I think, as you say, one of the benefits of this past year is it is now accessible to so many people. So, I know, you and me are using GPT and various other technologies frequently in our work, and I think a lot of people, across the world, but in real estate in particular, are now doing that. So people who previously, weren't software engineers, weren't developers, are starting to think about how AI applies to them and their businesses, and that's really interesting. And I think, a point we were talking about this before and you made earlier was that there's quite a lot of breadth to AI, and I think the exposure through GPT has sort of made people think about how they can use the other elements as well. So, some of the things which have been around a bit longer, generative design in a broader sense. Example would be the stuff layout one of the Pi Labs portfolio companies are doing with automatically generating layouts for building floor plans. That's a different kind of technology, but I think the broader set of possibilities has much more visibility because GPT and some of the image technologies such as Midjourney have just made it accessible to so many more people. So I think that's good. There is a hype cycle, and I think over the course of the past year, I think we've seen that play out with GPT in particular. So there was a time when I think people were looking at it really as a magic bullet that would solve every problem in real estate. I think what we've seen over the past year is it really the use cases separating out into things we know that it does well now. So there's a lot, for example, handling semi-structured or unstructured data, and there's a lot of that in real estate. Invoices, forms, Word documents that contain information that's useful. So making that available, summarizing that, that's a tool which I think a lot of people are using. And, right now GPT is pretty good at that, and it's adding real value right now. There are other applications where, we've sort of realized that it's something that needs further development. And I think, there's more sort of realism now versus a year ago about what GPT's good at and what it's not so good at. So, that's a learning process. And I think, again, like the more people involved in this, if an AI technology is limited to, a few dozen people working in academia somewhere, without that real world knowledge, without the attempts to apply it to real world problems, then, the world as a whole is not going to learn as quickly as it would if, you've got thousands, hundreds of thousands of people around the world, accessing that technology, trying to build real products on it. So So that's a good thing, in my opinion. And and the technology continues to evolve. It will continue for years into the future, and it will get better and better. We'll figure out more things it's good at, and that will add value across the economy, I think.
So there's an interesting thing around this, like your point around, like, a lot of this is not necessarily new, right? You've been in the world of AI for how long now?
Well, I started my PhD in 2001,
Yeah.
so more than 20 years now.
Yeah.
But AI, has a much
Even
longer
further.
history than that. And I
Yeah.
think actually, as soon as the dawn of computing,
Yeah.
people started thinking about using it for AI. And AI
Yeah.
sort of, it's changed in meaning over that time. But if you
Yes.
sort of broadly think about it in terms of problems that humans find relatively easy, but computers find hard. So playing chess, for example, was a traditional example of that. Simple chatbots, that kind of thing. As soon as people had computers, they started thinking about how to make them do things that humans can do. And there's been various sort of waves of AI technology over the years. Going back, in the sort of the 70s and 80s, you had symbolic AI, where you're really trying to encode the rules. So, to help a doctor make a decision diagnosing a patient, you might ask a whole load of doctors what they would do in certain circumstances and try and just write that, if the patient has a fever, then this, otherwise ask this question, and you create these decision trees. That's the sort of thing, people were doing. And
Is that like the first wave, what they refer to as that first wave?
Yeah,
if this, then that, and
there are different sort of names people give to it, but that was certainly one of the sort of the first mainstream applications was these decision support trees, and they actually work quite well in sort of quite limited situations. Fault finding in engineering or those sort of things. They've been around for a long time, and I think we just think of them as a routine application of computer technology now. In the 1980s, that became the first wave of neural networks, and the problem then was that computers just weren't powerful enough to do some of the things we're doing with neural networks now. So there were simple applications.
A bit like, this reminds me a bit. So the concept existed, but it was a bit like, I guess what I've seen some people make a retrospective criticism of Alan Turing on, which was that it was all well and good to say, can machines think? But it was a whole other thing to actually make it happen, right?
Yes,
So
absolutely. And back then, I think people massively underestimated what was required. I think there's a lot of excitement about computers that are brand new. Of course, they can be like humans. They can do maths much faster than any human can do. So surely they can do everything else the same way. And people had to try and realize it wasn't that case. But you're right. A lot of the sort of fundamentals of neural networks and that technology, really dates. Well, some of it's even earlier than that, but from the 1980s. And the limiting factor in at that point was the computing power. I think what's happened since then is, now we've got the computing power to build really large-scale neural networks. We've started to discover new things about them, and that's some of the sort of the emergent properties that come out when you have really massive ones and really massive data sets. So you kind of get to the next stage. It doesn't solve all of your problems having a bigger computer, but it allows you to do some more research, and you can figure out the next steps to build useful technology. Because those limitations, neural networks kind of fell out of favor. And there's something called, people refer to it as the AI winter, where, if you're a researcher, you were struggling to get funding to do your work because people thought, AI was a technology that had been tried and failed. When you sort of come out of that towards the end of the 90s, and this is sort of the environment when I was doing my PhD, you then got into these statistical methods, where you're using sort of quite different techniques, but the important thing here is you're learning statistical patterns in large amounts of data. So, and that sort of is very much a machine learning approach. So, you throw data at an algorithm and ask it to generalize to future examples. So, you throw it images, and let's say you're trying to determine whether there's a person in the image or not. You give it a whole load of examples of images which have people in, a whole load of images which don't, and you create something like a support vector machine, which is one of the techniques you can use to differentiate between them. train it all up, and then when you have a new image, you hope that it categorizes it. And that's good for these sort of categorization tasks at sort of relatively small scale, so sort of simple image or text classification tasks. And that's what people were doing, late 90s, early 2000s. And that was good. There was a lot of good theory behind, I think, the theoretical sort of development of the field really sort of took off at that point. And out of that, I think, and also, as you start getting into just the availability of more powerful computers, say GPUs, specialist chips, which really originally were optimized for graphics and games and rendering, but turned out to be really useful for the sort of computations you need to do for machine learning. That then allowed you to apply these statistical techniques to very, very large scale neural networks, and in particular in natural language processing, so looking at very large amounts of text. The other thing which enabled this was all of the text which is out there on the internet, right? There's millions, billions of documents out there on the internet,
and if you just each day,
constantly growing, up to date. All of the news sites are adding new content every day. So, you've got a very, very large amount of training data. You've got the ability to do the compute on very, very large scale neural networks. So suddenly something interesting happens, and they suddenly start being much more capable than you'd sort of imagine just by extrapolating what a small neural network can do. And we've seen a couple of sort of generations of that, because even this is really compressed timescales, because this is stuff which has sort of played out over the last sort of 5-10 years, where people started observing that large neural networks could pick out sort of patterns in natural language, which smaller ones just couldn't even start to do.
So my understanding of this was there was almost like that they happened across this, right? It was almost like you had your, if people can remember back to when it was really exciting to pick up your smartphone and have the predictive text where you'd be suggested the next word in a sentence. And then they started thinking, oh, okay, well, you can turn this instead of just one word into the next sentence that you can predict. And is it like, can you take us through what that looks like?
Well, I think in that situation, I mean, you're right that a lot of these things really are, generalization of the thing you've got on your phone.
Yeah.
And I don't think people sort of foresaw that, you take that and you give it much more context and you sort of tweak the architecture a bit, and suddenly you'd have something which started just behaving differently, and sort of emergent behavior out of it.
Yeah.
And that was very interesting. So, that was interesting. There's a lot of sort of theoretical breakthroughs around this time as well. So how you train these things up, the architecture, and in particular the transformer architecture, which is a sort of particular way of looking at the context it's been given,
right?
Which made a big difference. So, and that's this sort of virtuous cycle, right? As soon as people start using these, they start trying out new things. It becomes easier to experiment and make them better. So you sort of that flywheel is starting to spin up about this time.
Yeah,
and then sort of bringing it right up to date, you get to GPT, the first implementations of that. What you really see there is another sort of emergence where people talk about it in terms of zero-shot training. So the idea that previously you had these large, I don't know whether that's the right term, language models with large neural networks behind them, and you had to fine-tune them. So, you started with a base model, which, knew about the English language and knew about all of the stuff that's written in English on the internet. But, let's say you wanted to write a classifier to, determine whether, a particular document was relevant for a particular context. You had to fine-tune your model. You had to sort of tell it, these are the sort of documents we're actually going to be looking at.
Give it human context. Give it a human bias in some way.
And that was quite a quick process. The underlying language model takes a very long time on very expensive compute clusters, costs hundreds of thousands, millions of pounds to train. The fine tuning, something you can do on a laptop or a simple server on AWS quite quickly. So that was good. That was a big step forward, and it did create much more powerful tools for use in natural language processing applications. But then you go beyond that to the GPTs. What you've got is this zero-shot setting where you don't have to do that anymore. You just take GPT and you start saying, hey GPT, imagine you are working through a
Right.
database of financial documents. Can you
Yeah.
tell us the ones which have earnings summaries in them? Here's the documents. And that sort of zero-shot training where you don't have to give it examples, you just have to say, this is the task.
Yeah.
Here's the data, go and do it. That was another really big step forward. And that's where we are at the moment. And sort of the current generation of sort of GPT applications very much in that vein.
Right.
They that is much more powerful, but also much more accessible. And you suddenly get into this world where you have prompt engineering emerging as a new skill set, and it's kind of different to computer programming, right? So
So on this, right? So on prompt engineering. So this is an interesting sort of segue. Okay. So one thing I was going to touch on with you is that you and I, a couple of years ago now, I think, were having a lot of conversations around the no-code AI platforms that had been emerging in the construction sector, in the real estate sector. Speaking specifically a lot to say the skills shortage and how we ever going to have enough engineers to be able to get into the depths of a lot of these these tech applications, specifically AI applications in the built environment. We're going to need a higher or greater prevalence of no code, so that say, I wouldn't necessarily refer to them as regular people, but say non-technical people would be able to make use of these, right?
Yeah.
Now, all of a sudden, for the last 12 months, we've heard a lot around this prompt engineering thing. Conversations around linguists all of a sudden becoming valuable again to businesses, right? The way that you frame a sentence and how, we were speaking just off air before we came on here around the struggles a lot of people have had with visual styles of generative AI, right? How does that kind of come into this world then?
Yeah, I think it's it's a field which is developing very quickly, but I think the thing which is new here is it's kind of a new skill set. And if you want to build a real world application of these technologies, you need to have someone on your team who understands how to basically give the language model the right instructions to do the thing you want. And there's a lot of subtlety to this. There's things where very sort of subtle changes to the way that the prompts are structured actually makes a big difference to how well the model performs. So it's an interesting skill set because it's not computer science. You don't have to write any code. You kind of do need to be scientific about it. So you need to be able to do experiments, try things out, see whether it works, learn from that and try something else out. And you're right that some of the skill sets you might have if you come from a background in linguistics or writing, may be useful. I think actually, where this settles is a little bit up in the air still. But it's definitely, it's not computer programming. I think that's, the one thing that's clear, that there's a new discipline here. And I think that feeds into the sort of the academic side of it as well, right? Now we have these things. There's almost a sort of, I don't know what the right way to describe it is, but it feels almost like a sort of social science around them where you're trying to figure out how they behave.
Well, that's convenient for me because I'm a social scientist, so I feel important now.
No, I think it's going to be really important. You touched a bit on some of these vision models, and I think some of the no-code stuff as well is relevant here. We've got things like Stable Diffusion and Midjourney, which are generative AI for images. So, you can say, give me a picture of a cat on a table, and it will produce one, and you can get it in multiple different styles. I think those are, those are moving forward rapidly. I don't think they're as mature as the language applications at the moment.
Right.
But they're also really really important. I think some of the no-code stuff might be about sort of connecting these together and connecting them up to sort of real-world applications. So on a construction site, getting the data into the right place. You've got these cameras on your construction site. How do you get those into the AI system? In a way that's right for your construction site and so on. So I think there's also there is a room for sort of more traditional no-code approaches where you're sort of the AI is sort of one of the blocks that you're connecting together, but there's a lot of other stuff around the edge as well.
So on that then, right? So this is really interesting to me because I've tinkered quite a bit, right? As a social scientist rather than a hard scientist, right? Like yourself. And it has raised a few questions, and I've seen questions emerge, say around, okay, well, it's one thing to get a platform like Midjourney to produce. I've got an article coming out where I think I prompted Midjourney to reproduce the Houses of Parliament in central London. With clean, healthy Thames flowing across in front of it instead of the state of the Thames in London as it is today. and it produced something really interesting and fun and sort of novel for me to share in an article that I was writing. But it's a whole other thing to say turn a architectural sketch into an engineer's drawing. It's a whole other thing to do what layout is doing, to make a reference back to what you mentioned a little earlier. One of our portfolio companies with proposing floor plan designs based on a number of inputs, and of course some quite important inputs there being around compliance and those sorts of things. So there is quite a significant jump there, and this is what always fascinates me around the threshold, say, to which AI tech, right, AI products need to reach in order for it to either cause mass adoption and or offer a legitimate sort of alternative to the conventional approaches, right? So in the valuation sector, as an example, there's been a lot of controversy around the idea of using automated valuation models, including those using AI. We talk about the black box, right? Not knowing what variables are brought in, how they're processed to produce the output. So it seems interesting to me. Like, do you think like there is a threshold there on reliability, on accuracy, considerations around degradation when you're just throwing the kitchen sink at these solutions?
So I think so yes, and where that is, or sort of how much that's a concern, depends on the application. I think so. Sort of pick the extremes. I guess if you're asking an AI to generate designs that someone's actually going to go and build, engineering designs, then I think you're gonna want to be pretty certain that that building's not going to fall down. The technology is some way off that, and I actually think that's an area where some of the sort of more traditional approaches to AI you can imagine the sort of stuff layout are doing applied to to other elements of construction design as well, and and that's not a language model. That's a different kind of AI, but it is still saving time and producing better results. So that's a good thing. But you will want to go through the sort of certification process, and you'll probably you will want your algorithm to sort of give you confidence that it's going to work, and that will partially be explaining why it's produced a particular output as well as what it's produced. It's interesting you raise AVMs, valuation models, for properties, because in a sense, there's sort of two, like that's a relatively low risk. I mean, if you undervalue or overvalue a property as part of a portfolio, it's not going to kill someone. It may mean you lose some money, but that's true at the moment, right? The approaches people use to value portfolios at the moment have uncertainty, errors in them, and that risk is already there. So that's interesting. And I'd actually argue that the if you sort of view it in statistical terms, on average, how accurate do you need to be? The bar's not that high to be better
to beat
than
humans.
To be, I mean, and there's a lot of interesting sort of things to discuss here around, how precisely can a property be valued anyway. Right? It's worth what
real estate
someone
philosophy.
actually, it's worth what someone actually pays for it, right? So, that may be unknowable up front. And
valuation is an art and a science, they often say.
Right. Yeah. So that to me feels like an application where, it is sort of particularly amenable to, being good enough, and you need to do the science, and you need to understand the shape of your distribution, because this is an area where, I mean, depending on exactly what you're doing with the property, sort of having long tails. Yeah. Like, you could build an AVM, and let's say 99.9% of the time it is within 1% of the true value of the property, but 1% of the time, 0.1% of the time, one in 1,000, it is off by a factor of 100%, values the property twice as much as it should be. That's that sort of extreme tail event, depending on what you're doing with that and how much you're managing trading or whatever, that can make a big difference to the profitability of your portfolio overall. So
Not
so
just that, but do you think it also affects sentiment? Like if you think about like if you're using it for council rates, I'm just imagining that 0.1% is still thousands of homes.
Right, exactly right. If you're going to
that'd
apply,
make the news, right?
right,
That'd make the Daily Mail.
right, quite, and you get some bad precedent. And actually, another point in terms of how people like a lot of this, you do have to think about how people react to it. Like people don't like loss of agency in general, so you just say, this is the valuation because the computer says that's the valuation. People aren't happy with it. And actually, if you think about, in real estate, when you're really just using it as the basis for valuing a property that you might want to buy, then humans need to be convinced through a process that makes sense to them. So you do need to start saying, this is why I've produced this valuation, because there are these other properties in the area which I think are similar and they sold for this amount. And that's the application. People won't just say, I'm going to pay £1 million for this property because the computer said it's worth $1 million, right? You need them to say, because this one down the road, which is slightly better, sold for 1.2, and this one that's a little bit smaller, sold for 800. So
which unveils the black box a bit,
right, and it also constrains what you can do because because you're not just optimizing for accuracy at that point, and there's something else you're trying to do, which might mean you need to settle for a slightly less accurate model, but one which can produce an explanation. So it's very dependent on the application and what you're trying to do with it.
I just want to round out what we were talking about before on hype.
Okay.
Right? While you were talking about that, and your inconveniently timed PhD in the AI winter.
Yeah.
Right.
At the end of it, yeah.
At the back end of it. So, like, if we look at, like, I'm just looking at Google Ngram right now, which essentially shows the percentage of mentions of a particular topic or a keyword or something. We'll share it on screen for those watching visually. So we see, like, around the mid 80s there, we've got a peak of AI being used as a phrase in the literature, right? And we see it really come off the boil, right? Going into the final years of the 20th century, and we've got a bit of bouncing around there in the early. And of course, Ngram is always a couple of years delayed because they've got to scan all the books, and so Google every few years has an initiative to update this, and so the latest data we have for this is 2019. If we then jump over to Google Trends, we can see how artificial intelligence as a search term has shifted since the end of 2022, so 12 months ago. So I'm imagining when Ngram gets updated, we're going to have AI
another spike.
Right?
Yeah. I would say that there's a little bit on that other graph. Possibly if you search for machine learning rather than artificial intelligence, there might be a bit of a peak in the sort of late 90s. I don't know on that, but there was a little bit of sort of people didn't like talking about what they were doing as AI because it had a bit of a bad rep at that point. Yeah. So
you see that just here. It
sort of starts coming up again in the 90s.
You see it really coming up just here in the 90s.
But that's really taken off, in the last sort of 10 years or so as well.
Yeah, a lot. Yeah, that's really interesting. Do you think then, because there's always when the sector goes through the hype cycle, and this isn't unique to the built environment, it's not unique to subsectors of the built environment, but what we often see is, say, a little bit of cynicism emerge when we go through a hype cycle. We spoke about, examples of some positives from hype cycles you mentioned, and I've certainly seen this myself, that the not just the increased sophistication of a lot of professionals in tech broadly, not just AI, right? Them actually sitting up and paying more attention. But then also like the impact that has on innovation strategies within built environment companies, right?
Yeah.
So some positives. But then when we also see the cynicism emerge and people being like, they're calling everything AI. And we saw a similar thing with the metaverse hype only a couple of years ago, right? Yeah. Do you think there are, like, when you're doing due diligence, a big part of your role here at Pi Labs is on, being the tech and AI guru. Your eyes go over every company before we approve them. And so obviously you only see the ones that we like the most. You don't see the ones that we reject in the earlier stages. But do you see coming through the multiple channels that you have the increased misuse of the phrase AI, do you think it matters? Do you think it could cause another AI winter, potentially due to, say, the misuse of it, the race to get products to market that turn out to be inferior?
Yeah.
Right? Is there something around this that presents as an issue, a problem for us getting this to the requisite scale?
Yeah, I think so I see that hype and people just using it to try and get some funding for their business.
Yeah.
That does happen, and I think it goes through waves because I think, and it probably is something to do with the sort of dynamics in terms of the rate of innovation within AI. So there was definitely a period, maybe 5 or 6 years ago, where you got a lot of startups who basically just put AI in their name and didn't really do much. And for a while, I think that worked, and then people cottoned onto that and started asking questions. Well, what are you really doing with AI? And I think that was the sort of the understanding of what AI was and wasn't sort of became a bit more widespread. So people started asking deeper questions, and I think that reached its end. I think what we're seeing now is sort of that play out again with some of the recent innovations in these large language models, GPT and so on. I think people know that GPT is impressive. They maybe don't know the limitations so much, but also they don't know, and this is particularly relevant if you're thinking about building a defensible business and investing in companies. What you kind of just get for free because it's actually really easy and anyone could do it if they because I think the thing to remember with the GPTs of this world is there's open source models aside, and maybe we'll come back to that. There's sort of 3 players in the space, and no one else is building their models from the ground up. Because of the cost and complexity of doing it, mostly you're using OpenAI's API to get into GPT. So what do you get for free just because it's GPT versus where is the innovation if you're evaluating a startup that's built a product on top of GPT? Being able to evaluate, is that genuine, unique, defensible innovation, or is it literally just repackaging something that anyone has access to? So I think we're seeing a bit of that where people are doing things which seem impressive, but they're actually if you know how the underlying technologies work, they're really easy to do. And maybe so not defensible. Maybe they don't scale. Scaling is the wrong word. Maybe they don't generalize very well. So you can make a great demo, but you can't make a real product out of them very easily. So we're seeing a bit of that, but I think we're also if you cut beneath that, then we're also seeing genuine innovation on top of the sort of core GPT language models, and the models themselves are evolving very rapidly. Very, very recently, we're starting to see things like code execution, so where you're asking GPT to create Python code or SQL code to access data and then execute it and give you the results. That's a new thing, right? So and ways to chain requests, so you're not just having a single input into GPT, but you're pulling that out, processing it, putting it back into GPT, and so on. So those kind of applications, I think, is where you're starting to get some depth to them. But it is a bit difficult if you're not someone who's actually spent a lot of time playing around with them. It's difficult to sort of figure out, who's adding value on top of the underlying technology versus people who are just trying to repackage it and wow people with science.
Okay, so while we're on this topic then, because what we'll do is we'll quickly touch on, I think, on this open source point, which I think is a really good and important one.
Yeah.
But we'll just cover it quickly because what I then want to look at is some future gazing, making some examples of some of the companies that we've proceeded with, that we've invested in, why you liked what they were doing, how they were differentiated based on that point, and how there is some potential then for AI to maybe even reverse some trends that we've seen with tech in the built environment over recent years, right? So let's first then go into this point around open source AI.
Okay, yep.
So there's been some fascinating, controversy around open source AI recently, which was recently brought to the fore by an adjunct professor at Stanford, who I believe was the co-founder of Google Brain from memory. And Google Brain. And his point actually to an Australian paper, funnily enough, very recently, Australian Financial Review, was that the big players in big tech, the big names of big tech, who were expressing all of these fears and concerns around the rate of development of AI without it being regulated and without controls being put into place, was an existential threat, essentially. And this academic said there are large tech companies that would rather not have to try and compete with open source. So they're creating fear of AI leading to human extinction, right? So they're playing up this fear around the singularity, around AGI, artificial general intelligence, hearkening memories of Terminator and Skynet and all these sorts of things, right? So you're in the thick of this. You've very well in the past differentiated AGI from the current applications. What's your view on the issue of open source and of the fear of the big tech giants of this?
Yeah. So there's quite a lot to unpack in that, but I think one thing, I think there probably is an element of the big tech companies wanting regulation because, any regulation in any industry favors the incumbents, favors the big players who have the resources to meet it. Yeah. So I can see that. I think if we look at open source AI, it's interesting because, right now I think it's fortunate for the big players that, it's just not been possible to build language models at that scale without huge, amounts of resources, hiring an army of PhDs and, running, these training jobs on compute clusters that, the time on them literally costs millions to just do one training run on this. So, I think, that's been the case just because of the state of play of the technology for a while. What we're starting to see is the promise of these so-called open source models. And open source models, the open source elements of a bit of it, right? That the architecture and the weights are out there in the public domain, so that you can, play with them yourself. But also models where it's practical to run them with much lower computing resources. And that's really the innovation here, is this idea that maybe something which is much smaller. You measure these things in terms of number of parameters, how many billions of parameters they have. Models with much lower numbers of parameters, and therefore ones that you can maybe, if not on a laptop, you can maybe, if you're a small startup, you can buy enough time on AWS to train these yourself. That is an interesting development. And, there's nothing about the technology which says it has to play out that way, but I think it looks like it is. And I think, from my perspective, that allows more innovation, more people playing with these things. And a lot of the things which have enabled these open source models, actually, it's to do with the data sets. So rather than just throwing the whole internet at it, which, we know there's a whole load of junk out there on the internet, being more selective, being more sort of thoughtful about how you design the data set. So, so that is a positive trend, from my perspective, and one which, I think, does make the technology more available. It means that the big players don't just have this natural moat of these things are just inherently expensive to build. So that's interesting. I guess the sort of broader fears here of AGI, singularity, that kind of thing.
Terminator.
Yeah, Terminator. yeah. Is it's easy to be afraid about something new and with seemingly sort of sophisticated capabilities. I think the risks right now are more to do with sort of I guess the sort of the harm through bias and through economic impact and through loss of agency. If the AI we have right now is used in a way which is discriminatory, or where it means people lose their jobs because an algorithm has said they're not performing well enough rather than a human, that sort of thing. So I think that's something to focus on, in the short term, is how do we make sure these models are fair? How do we make sure that computer vision models are just as good at identifying people regardless of their skin color? We know that's a problem at the moment. All of that kind of thing. I think we do need to be careful as these things evolve. But I don't think you do that just by restricting development to a few large companies. I don't think there's any reason to believe they're sort of particularly well placed to be the ones who decide how to develop this responsibly. And government regulation as well. Like no one knows. This is all new. So I don't think governments yet have a model for the right way to regulate this technology either. Right. So I think it's an ongoing discussion, and as many people in that discussion as possible about the responsible way to deploy AI is the way to keep it safe.
All right. Okay, so finally, what I want to look at is the outlook for the built environment when it comes to this, right? So we've spoken about some of the challenges around the hype and the risk of a second AI winter or something like that. If a lot of these applications are just layered on top of some open source tech, but how about if we look at some of the investments that we have made at Pi Labs, right? Some of that you've overseen and that you've liked. I know you have a really close relationship with a number of our founders, really at the frontier in their spaces. Some are generative AI, or you could be align them with that concept. Others, in completely different parts of AI. It's a very broad church. That's something I've very much learned from working with you and kind of dabbling in this field quite a lot naturally as a requirement of my job. It's so broad almost that it's hard to define. You did a good job at the beginning. Yeah. But if we look look at the environmental transition and the role that AI could play in that for the built environment. Contilio is an example of one of our portfolio companies who's been around for a long time in startup world, in early stage startup world. Kicked off in Europe. They're being used in the Middle East. They're deploying, say, LiDAR scanners and things like that, preventing rework, those sorts of things. Yeah. What are your perspectives on applications like Contilio in not being just what you refer to as like a superficial layering?
No, I think Contilio is a good example because I think their tech runs quite deep. I think the thing which is a standout for that company is just how thorough they've been. One of the many things which stands out with that company is just how thorough they've been. With the underlying technology, it works really, really well, and it has a clear application, as you say. It's helping to avoid waste and rework on construction sites. That saves money, but it also helps with the environment. So. We all know that the construction industry is an area where there's a lot of opportunity to be part of the solution in the environment and climate space. So, Contilio is a really, really good company. I think, they're doing exactly the right thing in terms of, being very measured and careful and thinking very carefully about, how AI adds value, and it genuinely does with what they're doing. It enables a product which is unique and which is very useful for a lot of companies. I think the traction that we're seeing with them is an example of that. I'd also say if you look at some of the stuff to do with data sort of pipelines and just making sense of all of the data that's there in construction, Qflow is another company in their portfolio, and they're doing similar things with the same aim of reducing waste and improving the environmental position of construction. So and that again is it's not sort of big flashy AI for the sake of AI, but it's a very, very targeted application and it works very well. So I think that sort of thing, that and all of these things, the fact that these companies, even some of them who aren't sort of shouting from the rooftops, hey, we're an AI company, are using this technology and adding real value now, and that's confirmed with traction with customers who are driving value from the products. That's what gives me confidence that if there is another AI winter, it won't be back down to ground zero. So yes, some of the hypier applications might sort of fall out of favor a bit, but I think there's enough which is already established that people aren't going to stop working on it. It's not going to be something that no one could get funding to do a PhD in. Because the value's already been proven. So I think that's really interesting. So I think there's a lot of sort of positive potential out there. And as I said before, I think some of these applications for language models, we know a lot about where they're strong. Other applications are still to be determined. So I think if we what probably has to happen in the future is not viewing AI as a monolith. Like it's not one thing; it's lots of different things. It has other applications, and sort of, maybe that's a risk. Maybe that's the thing we need to sort of break, is this idea that if one AI application fails, then the whole thing's no good. That's not true. We know there are enough applications where we know it certainly does work. That the whole edifice doesn't have to come tumbling down just because one of the bricks turns out to be not quite as strong as we thought.
And you know what? That should be quite straightforward reasoning for those in the built environment listening to this, because you could make the same argument, right? Like, say, infrastructure is very different to real estate.
Right,
and commercial real estate is very different to residential. They all perform very differently to one another. They require different inputs. They have different customers. I mean, we're all human naturally, but we're all very different humans doing very different things in very different buildings, right?
Yeah.
Okay, well, I think that's us, Phil.
Great.
Yeah, I think that's
interesting.
Yeah, very good conversation. Hopefully, at the perfect level that is enough depth for the widest audience of ours. So thanks for that, and for those tuning in. We have coming up in the coming weeks and months quite a lot of output from the PyLabs research team, including Phil, on this topic, on the topic of AI in the built environment and its role in the built environment's environmental transition. So again, thank you for that work that you've done, and I'm sure we'll get plenty of input and feedback on that in the coming weeks.
Yeah, looking forward to it.
Beautiful.
Great.